Question number 25. A train moves at a constant speed while emitting a sound wave of frequency f0. Okay, at t equal to t0, the train passes through a station. Which graph shows the variation with time t of the frequency f of the sound wave as measured by an observer standing on the station's platform? So most of the moment you read the question, they will think that A is the right answer, but A is not the right answer. D is the right answer. Let us see how is D the right answer. Now let us say this is the train. This is having a horn here, which is having a frequency f0, and you are standing on the platform at this point. Now as it reaches over here, how do you relate frequency, observed frequency? Observed frequency is given by f dash is equal to f into v divided by v minus u source. This is what it is. Now u source, it says constant frequency, which means this value is constant, right? So and it's moving at the uniform velocity, uniform speed, right? So therefore the velocity at this point, every point, the velocity is not changing. It is going to be the same, which means the value of f dash until t equal to t0 is always going to remain the same, right? So it does not increase, though we have learned that somewhere the frequency increases. Okay, now as you observe here, with respect to time, the frequency remains the same over here. Okay, so it remains the same over here, but so therefore as at t equal to t0, see, it does not depend upon the displacement at all anyway, right? The value of us is changing. Okay, then it's possible. Okay, then it can change. So here also, let us say for example, what do we actually do? Okay, when we say f0 is the actual frequency, f0 is the actual frequency. Let us interpret it correctly. F0 is the actual frequency. The frequency which the observer at this point will have is f dash is equal to f0 into v minus vs. Let us say if f0, f0 is equal to something like 300 hertz. Let me take some example. 300 hertz. And then this us is equal to, let us say something like 20 meters per second. 20 meters per second. Train is moving towards 20 meters per second. So substituting all this, you get f dash is equal to 300 multiplied by velocity of sound, 340 divided by v, which is 340 minus 20, which should be 320. When you do this, you get 300 into 34 divided by 32, which will not change. Okay, which remains a constant with respect to time. See, the frequency that you hear here is different, of course, but that value will remain a constant as long as the train doesn't cross you. So therefore, it remains a constant here. It remains a constant. The moment the train is at this point, what will happen? The frequency will now be the same. But after this, at this point, okay, this is the point of the observer. Then when the train moves away from you, what will happen? The frequency will now decrease. Why is it decreasing? Because the equation now becomes f double dash is equal to f0 into v divided by v plus us. Okay, which means here it will become 340 over here, right? So this is 340 plus 320, which should be 360 over here, right? So it should be 300 into 34 divided by 36. The denominator increases. When denominator increases, f double dash should decrease. F double dash should decrease. So it's decreasing over here. And between them, there's a smooth transition. So you get like this over here. Okay. So it does not increase. It does not increase. It does not remain the same forever. Okay. So therefore, D is the right answer.